Everybody, it's Miss Williams. This is Chapter 2, Section 2 of your statistics course, density curves and normal distribution. So things that we already know about quantitative data. So if we want to discuss quantitative data, first we need to plot your data. Then you have to look for patterns, shape, center, spread, and outliers. Then you would need to calculate numerical values for center and spread. When do you use mean and standard deviation, and when do you use median and interquartile range? Now we're going to add one more step to that and say that sometimes the overall pattern of very large numbers of observations is so regular that we can describe it as a smooth curve. Alright, so sometimes we're going to take quantitative data and we're going to be able to describe it as a smooth curve. So a density curve, which is the smooth curve we're referring to, is a curve that is always on or above the horizontal axis. And it also has an area, that should say an area of 1 underneath it. Okay, you always have an area of 1. On a density curve, the mean and median are the same if the curve is symmetrical. If the curve is skewed, the skewed part will pull the mean further down the skewed part. We've talked about this already in Chapter 1. Alright, so it works the same way. So we need to things about normal distribution. The normal distribution is described by a normal density curve. Normal distribution is defined by its mean and standard deviation. So whenever you talk about a normal distribution, you have to know the mean and standard deviation. Mean is represented by the mu symbol, and standard deviation is by that cursive O. Sometimes it can be abbreviated by, we'll call the normal distribution curve N with mu, comma, standard deviation. So they can abbreviate it that way. Alright, so that's something you need to know. This is something you did in Algebra 2, or should have done in Algebra 2, the 68, 95, 99.7 rule. So those are the percentages of the amount under the curve between 1, 2, and 3 standard deviations from the mean. So as you can see, the mean is in the middle, and then if you go 1 standard deviation above and 1 standard deviation below, you end up with 68% of your data. If you go 2 standard deviations, you would end up with 95% of your data. And if you go 3 standard deviations away from the mean, you end up with 99.7% of your data. Alright, those can be broken down since it's symmetrical, 34, 13.5, and 2.35 going away from your mean, as you can see there. The standard normal table. It's table A and it's located in the back of your book, and it gives the area under the curve to the left of the given z value. Oh, I did a v twice, sorry about that. The normal table helps us because we all know that a value is not always going to fall exactly 1, 2, or 3 standard deviations away from the mean. So the table A helps you figure out how much area is underneath the curve at a particular z-score. So how would I find the area of a normal distribution? The first thing I'm going to do is find the z-score by using x minus the mean over standard deviation, and you always take it to the nearest 100th place. Then you're going to go to the back of the book and find the table and find the 1s and 10th place of your z-score on the right, that should say left, on the left-hand side of your graph of the table. Next, you move across the row until you're in the correct hundredths column. Finally, you refer back to the question to decide if it's asking for the area to the right or to the left of the z-score. Alright, table A will always give you the area to the left. Alright, to find the area to the right, you would need to subtract the value in the table from 1, because density curves have an area of 1. Alright, and so the area to the left of the z-score and the area to the right would have to add up to 1. So if the table gives you the area to the left, to find the area to the right, you would need to subtract that value from 1 that you found in the table. Alright, we're going to do some more of this in class, and I will see you later.